Hello students. In the previous classes we have learned about how to use the chain, what are the errors you use the chain, the compass and the errors involved in the compass, then the theodolite, the errors which you come across in theodolite, tachymeter, curves and all these things we have learned. So when you are using these instruments you always have to learn about the error also. So using modern techniques and modern equipments, the not just the error can be reduced, the you can never overcome the reduce, you can reduce the overcome, you can reduce the error. Say for example, if you are saying I have an error of 1 meter, if I go 1,000 meters, let us say if I use chain, I have 1 meter error of 1 meter error if I calculate the distance of 1,000 meters. So same if you go with a modern instrument or high equipment, then you can get 1 meter if I go for 10,000 meters. So the difference is that. So using modern equipments, you can overcome this, reduce the errors, and also this save a lot of time. These are so in this video we are going to learn what are these modern equipments, how they are used, and what is the background of working of it and all those things. So the topics which we are going to discuss in this video are what is this EDM is all about. EDM is something different to other domains or other engineering streams, and EDM related to our serving is totally different. EDM stands for electronic distance measurement, and then we have auto levels, then we have digital levels, then we learn about this total station, and then we also learn global positioning systems. In the next few slides we are going through it. So what is an EDM? So EDM is it's a distance measurement. Just it calculates the distance between 2 points uh, using a modulated electromagnetic wave, which is taken from a spectrum. This electromagnetic wave or can be of a microwave or infrared, whatever. The source is from your instrument, and we have the point. If you want to calculate the point A to B, so we set up our EDM machine at A, and at B we have a receiver. So the source projects the this modulated ED electromagnetic wave, and the receiver receives the signals with the duration and calculates the time of duration of that wave. So when you know the time of the travel of that wave from A point to B point, and when you know the speed, then the distance is given by, the speed equals the distance by time, then distance is given by speed into time. So the speed, the electromagnetic wave is normally taken as the speed of light. So the speed of light is multiplied with the time taken by the wave to travel from A to B. So this is basically the working principle of EDM. And some instruments use microwave, instruments use infrared wave, some other use some other. So basically the same. So you have a receiver and you have a source where the distance is calculated. So I'll show you, this is the one of the this is the handheld EDM which you are seeing now, and it can measure accuracy of 10 mm. Like I said, you can reduce the accuracy, but the you can expect some errors in this also when you're using huge distances, like the signals is traveling through a medium. Air is a medium. When you have a thick fog or when you have rain, then you cannot expect the EDM to be that accurate. So if you have a remote or if you have contact version, you can just put the your machine onto a tripod, and you can just move your receivers, and immediately you can find out the distances. So it's very easily, if you want to have the traverses or whatever, right? So directions are not, we are not getting the direction, we are just able to get only the distances. So this is the auto level is a very most common usage. It's now dumpy level is no more of use. So the auto levels are very fast because there is a less chances of error. The magnification there is more, range as because magnification more, range is also more, and image whatever it is it's have erected such a way that you can get the less chances of taking down the readings from the star. Then we have digital levels. So digital levels are such an instruments where you the calculations on paper is also totally reduced. All that you need to have the prism or uh, the receiver on the point where you wanted to calculate the level, and just click the button. You can directly calculate uh, the level of that point. These are the commonly used uh, digital level instruments, right? So these are all of them, right? So this EDM, so electromagnetic measurements, it uses the principle of the modulated electromagnetic beam. The instrument is called as a transmitter, and then now there is no receiver now. Now we keep a reflector there. Let us say we put a mirror there. So this electromagnetic wave, modulated electromagnetic wave, passes from one instrument, from the instrument, and it gets hits the reflector, and it comes back to the transmitter. So the transmitter itself is now inbuilt as a receiver also, right? So it calculates the time taken from the starting to the time taken to get back. So the same, the time is two times. So this, if you divide it by two, you will get the average time. So it taking two calculations at a single time, and it can give you more accurate values if you have these electromagnetic modulated electromagnetic wave, where we have the transmitter and receiver on the in the instrument itself. So it calculates double the distances, but so the instrument propagates, reflector comes back, then it calculates the value, but double the distance it calculates, it gives you the accurate values. So these are all instruments where you can do this. These are all previous instruments. So the calculation of this instrument, the operation of instruments involves setting up your instrument, aiming at the point, then measure and recording that. Simple four buttons. The common errors which you can expect from the instrument. The errors can be errors are very less when you compare with the analogical analog instruments where you have paper, pen, writing, calculation, manipulations, all of this. So you can completely overcome all those things, right? So then you have total station. The total station is a combination of EDM and outer level, both of them. So from EDMs you calculate the distances, and uh, from outer levels to calculate the distance is the combination of EDM and the digital level. So the total working nature of your total station works on principal coordinate geometry, where x y points taken into consideration, and we can lay out the entire plan, entire contours. You can do so many things from there. So you have a digital display, you have keyboard, it stores the data. It can be plugged into the software. It can plugged into the computer, and with the help of the software you can plot the contours. So the normally angle measurements you can do, the distance measurements you can do. You can put control points, survey points. Then you can detail mapping can be done, contour can be done. If you want to set out any construction work of a building or a factory where you have a huge area, then the points are very important. If you well, total station makes it very simple. If you have the from the boundary, if you have a 250 meters inwards towards the line, if you want to have a factory, then 250 meters distance measurement with the tape, it can be gone across. But what if you know that point X, Y, Z, and if you have it tabled along with you, if you just take some reading and just give it just one click of button, it just takes 15 minutes of time rather taking a whole day if you want to have the corner of the building. So it's that simple in setting up the mostly it is used in the construction setting out works and detail mappings. So this is the general picture. These instruments is manufactured by different companies. It doesn't like that you have only Nokia company, like you have mobile phones, different companies. You do have also have different companies manufacturing total stations. So the one of them very famous is Sokia Lika, and for institution purpose you can buy a Pentax something like that. Okay, and it costs around 3.5 lakhs to 2.5 lakhs. It's not that much, uh, less. It's complicated. It has more money to it attached to it. Then you have storages. Then you have a battery there. Then you can do all these points, right? You can find out area, you can find out setouts, you can find offsets, you can give offset points, you can then remote distance which you can't go, and then you can do resections. Then missing light you can find out. All these things you can do with a simple means of button. All these are the instruments. Remote sensing, it's not necessary. You can, um, but these are all related to remote sensing. We study in fourth year. So we have the GPS. So GPS we already discussed. We'll discuss in the next video, but then we will give an introduction in this. GPS is there. Um, the position of a point is given to you with related to time using the satellites which are orbiting around the earth. So that is what the GPS whole definition is. So you have a series of satellites orbiting around the earth, and they always signal their locations, right, in the form of pseudo code. So and the receivers they absorb the transmitted data, and they process, and they'll and related to their satellites, and its position, the receiver position is calculated. So many of them think that the satellite is calculating, but it's just not. The receiver inside the receiver calculates the location. So we'll discuss in detail in the next video. Thank you.